For my first special quadrilaterals proof, I'm going to prove that if the original shape shown here is an isosceles trapezoid with upper-lower bases of AB and FC, and if AB and ED are congruent, and EF and DC are congruent, then the resulting quadrilateral ABDE is a rectangle. And the way I'm going to do this, I think it would be relatively easy to prove that this inner shape is a parallelogram. And if I can do that, if you take a look at the book here, there are a couple of shortcut methods. I can prove that a rectangle has 4 right angles, but I can also prove that if it's a parallelogram and it has only 1 right angle, that's going to force it to be a rectangle. Second of all, I can prove that if it's a parallelogram and the diagonals are congruent, that it's a rectangle. I'm actually going to try that second approach. So the first thing I'm going to do here is I'm going to prove that the isosceles trapezoid I have here has a parallelogram inside it, ABDE. Okay, and the way I'm going to do it is by proving these outer triangles congruent to each other. Okay, first of all, I know that AF is congruent to BC, and the reason being legs of isosceles trapezoids are congruent. So I can go ahead and mark those congruent. And I also know that base angles of isosceles trapezoids are congruent, so I can say that angle F is congruent to angle C. Base angles of isosceles trapezoids are congruent. Or, of course, I could write these in if-then form. If a quadrilateral is a trapezoid and is an isosceles, sorry, that's isosceles trapezoids. If a quadrilateral is an isosceles trapezoid, then its base angles are congruent, if I want to write it out the longer way. And as a result, that means that triangle FAE is going to be congruent to triangle CBD by side angle side, which tells me that AE is congruent to BD because they are corresponding parts of congruent triangles. Okay? Well, why is this so important? Main thing here is this. If I can show those outer triangles congruent, and then I can show their corresponding segments congruent, I've now shown that I have a quadrilateral with both pairs of opposite sides congruent, meaning that that central shape is a parallelogram. So, I'm going to state that ABDE is a parallelogram. And this is going to allow me to use one of my shortcut rules because I know it's already a parallelogram. So if a quadrilateral has both pairs of opposite sides congruent, then it is a parallelogram. Okay, so now I know opposite sides are parallel, any parallelogram relationships I need. Well, if you go back and take a look at the book, one of the methods I can use to show that I have a rectangle is that it's a parallelogram with congruent diagonals. My thought is that if I draw in diagonal AD and I draw in diagonal BE, that I'm going to be able to show these two overlapping triangles congruent relatively easily. Then I could show that those diagonals are congruent, and at that point I would have my rectangle. So the way I'm going to do this is, of course, first of all I need to draw those segments. So I'm going to draw AD and BE, 2 points determine a segment. And to prove these congruent, I've already got a pair of sides for the two triangles, and I have an angle for the two triangles. I just need to prove that this side is congruent to that side, and that's just an addition property. So FD is congruent to EC by the addition property. I add congruent segments to congruent segments, they're congruent. And what this is going to allow me to do now is to prove those overlapping triangles congruent. In this case, FAD congruent to CBE. Right, so triangle FAD is congruent to CBE, and in this case that is by the side angle side rule. And the reason I did this is because side AD and BE are corresponding parts of those congruent triangles, and as a result I will have shown that this is a parallelogram that has congruent diagonals. So step 12, AD is congruent to BE, and those are corresponding parts of congruent triangles. And now I can say that ABDE is a rectangle. And the reason being, I already proved that it's a parallelogram, and now I've proved that the diagonals are congruent. So if a parallelogram has congruent diagonals, then it is a rectangle. And that should complete this proof.